if I would have to describe another presenter, I would probably spend 20 minutes describing what this guy did for the front-end community in regards to Angular and also micro frontends development. Guys, I would say Google developer expert, Microsoft MVP, O'Reilly author, and international speaker. What's more, the next speaker is running a company that provides a great front-end trainings for newbies, but also for senior developers or architects. If you haven't heard about him, it's probably the last moment you should get to know Manfred Steyer. So, ladies and gentlemen, a big round of applause for Manfred Steyer.
Thanks for having me. It's a pleasure to be here. And this last talk today will be about advanced stuff regarding module federation for micro frontends. And I think so far you've heard a bit about micro frontends. We had 2 amazing talks so far. And so we all know micro frontends are about subdividing a huge application, a huge frontend into tiny parts. And we do this for one special reason, namely, we want to assign individual themes to all those parts. Those themes shall work in an autarkic way. They shall work independently without influencing each other, without the need to communicate too much and to coordinate too much with each other. Or to put it in another way, this all is about bringing back the agility of small teams to a huge overall software system. I think this clearly shows that micro frontends are first and foremost not about technical goals, but they are about organizatorical goals. They are about sharing your team and scaling your team. However, I have a bad message for you. It's about this guy here, your customer. Your customer is not interested into micro frontends. No, they are not interested at all. What they want to have is one integrated system that is able to provide everything they need to use. And that means at runtime, somehow we need to integrate all those moving parts, this micro frontend, that micro frontend, and so on, into one integrated solution. I'm calling this solution the shell or the host. This one integrated solution looks like one single page application for the customer. And we really need to do this at runtime because micro frontends are about implementing, but also compiling and deploying stuff individually. And as everything is individually deployed, we need to grab those moving parts at runtime and present them somehow. The thing is, runtime integration, displaying something here from over there, was quite difficult in the past. It was always possible, but we needed a lot of tricks, a lot of dirty tricks and workarounds. Several years ago, before the term micro frontends was even coined, some people used iframes. Not because they wanted to use them, but because they had to use them. There haven't been much alternatives. Then people started with loading web components on demand. Several frameworks show up like single spar, we've heard about it today, that help to load this or that into the same browser window. However, since about a year and a half, we really have a rock solid solution for all of this, for loading an individual deployed application into the middle of yours, and this is module federation. It's really rock solid and straightforward. All you need to do is to import something from over there. You can import something from over there, a component or an Angular module or just a function, an ECMAScript function, and so load it into the middle of your shell. It's really as easy as that, more or less. However, when we start dealing with module federation, when we start importing something from over there, from a separately compiled and deployed application, there are several questions that are coming up. Questions like, how shall we proceed with version mismatches? What happens if we have different versions in there and if we only find out at runtime? Shall we use a mono repo or multiple repositories? Shall we go with dynamic federation? And if yes, how can we make it work? How can we load something we only know at runtime? We did not even know at compile time. Perhaps we don't even know the number of the micro frontends at compile time. So here we need a very dynamic scenario. And last but not least, how to deal with multiple frameworks and versions of those frameworks if we really, really need it. Or as I would put it, how to deal with a Frankenstein architecture. You know, this Frankenstein guy that was assembled of different parts of different dead bodies. I will give you an answer to those 4 questions today, but before we get started, I want to give you a little tiny primer into module federation. It's really a short primer. I've talked a lot about this topic recently, so I will just limit myself to 3 slides. Perhaps there are 4 slides, I'm not completely sure. This is just about getting everyone into the boat. But before I start, let me introduce myself. I am Manfred, I'm a trainer and consultant for Angular, and I'm helping a lot of companies with Angular in the enterprise environment. And hence, micro frontends is quite an important topic for me. Not the only topic, but quite an important topic. We already did micro frontends before the term was really used out there. I'm doing workshops, and you can find out about those workshops here. I'm doing them, or we doing them remotely and on site if the current situation allows for it. Besides this, I'm quite connected to the Angular community. I live in Austria. I do a lot of stuff in Germany, and I'm always happy if I can work together with people around the world, which is nowadays quite easy because a lot of stuff happens remotely. Okay, let's get started with the primer, Module Federation 101. Well, the idea is to load something from a different application, from a separately compiled and deployed one. And for this module federation gives us 2 roles. The first role is the shell, or as it's called officially, the host. And the second role is the micro frontend itself. The official name is the remote. Both is configured. Both is configured using the Webpack configuration. For instance, for the shell, I can map paths. I can say, well, every time I'm importing something from MFE1, from this URL, I want you to grab over to this application and load something from over there. And over there, I can say, well, I want to expose this or that ECMAScript file, a file with a component, a file with an Angular module, a file with, let's say, just a function or a class. And of course, the shell is not interested in our full paths and file names. It's not interested that we find this and that under x/y/z. And that's why we can define a nice alias. This is everything the shell needs to know. This alias to grab it from over there. And then something beautiful happens. I guarantee you, you will love it. Then all you need is just a dynamic import. And dynamic import using the map names, MFE1 from this side, CMB from that side, and this allows you to grab something from over there. This is really beautiful because that means that your framework, in this case Angular, does not even recognize that you are going with micro frontends, that you are loading something that was not known at compile time. This is completely agnostic to your framework. All your framework sees is, hey, there is a dynamic import, so let's do lazy loading. However, underneath the covers, Webpack Module Federation is doing the heavy lifting. It knows exactly what to do to grab this component from over there. And that means you can use your framework as is, as it was intended to be used. You don't need to tweak it. You don't need any meta framework. Just use it as is and Bob's your uncle. You can also share libraries. This is perhaps another cool feature, perhaps one of the best features of Module Federation. You can say, well, I'm using Angular here. I'm using Angular there. So let's only load it once. Where's the point of loading it 5 times? Just because of having 5 micro frontends, or 10 times because of having 10 micro frontends. No, just load it once and share it. It's really as easy as placing the library in this configuration section here. Of course, I already hear you saying through the Zoom client, hey, when we share libraries, we can have version mismatches. And do you know what? You are right. But also, Module Federation got you covered. They implemented several features for dealing with version mismatches. We will come to it in 1 or 2 minutes. Before I show you how to deal with version mismatches, and before I show you how to deal with all those other advanced ideas, let me show you how to use it together with Angular and especially the Angular CLI. So the thing is, the Angular CLI is already using Webpack 5 underneath the covers. That means it ships with Module Federation. We just need a little tiny plugin to switch it on. And of course, you could handwrite such a plugin, but you don't need to do it. I already have one here, just ng add it and Bob's your uncle. This will also generate a configuration file for you. You need to adjust it a little bit and then serve your application and everything should be fine. Let me show you a little tiny demonstration on this. In this demonstration, here I have my shell, and here I have my micro frontend within the red dashed border. You see the micro frontend runs here on localhost 3000, and the shell runs there on localhost 5000. And no, this is not a prerequisite, not at all. But just by going with different origins, I can prove that I'm really loading something that was separately compiled and deployed. However, feel free to deploy everything on the same server. It's totally fine. And when I'm clicking here to flights, then we see that the micro frontend is loaded into the middle of my application. I'm seamlessly loading this application into the middle of that application. How nice is that? Okay, if we look at this at runtime, by having an eye on the network tab, we see it just looks like lazy loading. On demand, this file here is loaded from over there, and this file here only has about 10 Ks, which is literally nothing. Because first of all, we are in development mode. And secondly, I'm sharing Angular itself. That means Angular itself doesn't need to be loaded twice. It's already there. We can reuse it. As you see here, this really leads to tiny bundle sizes. If we look in the source code, everything we need is a traditional Angular application. Here it's called MFE1. It's a traditional Angular application, nothing special in there, but it gets this Webpack config JS to define which files to expose, which files to load, which dependencies to share. And we have the very same situation for the shell. Traditional Angular application. If I used React, it was a traditional React application. If I used Vue, you know, it was a traditional Vue application plus this little tiny webpack config. We will have a look at it in some minutes. As mentioned before, the first thing you are very likely wondering is how to deal with version mismatches. I mean, sharing libraries is nice, but what's if we have different versions of those libraries? The first micro frontend needs this version, the second micro frontend needs that version. Well, the whole truth is that because of this, module federation was actually implemented twice. It was implemented once, it went into beta, and they saw, well, it works nicely, but we need a better story for dealing with version mismatches. And that's why they implemented it one more time from the scratch to bake this topic into the DNA of the framework. And even the default behavior is quite smart. The default behavior is about selecting the highest compatible version. So let's say we have version 10 here and version 10.1 there. By default, only 10.1 is loaded because this is the highest compatible version, the highest minor. It should be backwards compatible to 10, at least in theory. However, if there is not a thing like a highest compatible version, like here we have 11 and 10, two different major versions, by default, module federation loads both. And this is beautiful or a disaster. It really depends on your very situation. If we talk about tiny libraries, this can be okay. Of course, it's always a hit on the bundle size. But if you say, well, bundle size doesn't play any role, then it might be fine for you. Besides the hit on the bundle size, if we talk about a little tiny library, then it should be fine. Because in this case, this part of the application is not concerned if that part is using a different version. If we talk about your major framework here, it's a bit more complicated. About Angular, for instance, because this means you need to bootstrap Angular twice, once in this version, once in that version. And yeah, it's doable, but it's not officially supported and the road is quite rocky. Hence, the recommendation from the Angular team and also my recommendation is, if somehow possible, stick with one version of your major framework. Your future self will thank you for this because this makes the road less rocky. But if you really need to mix and match different versions, there are ways of doing it, but you need to take some pain, of course. We will talk about it a bit later. Another option you can do when configuring your dependencies you want to share, you can define a singleton. Singleton means Highlander principle. We all know the Highlander principle, there can only be one. And this is the case here. This guarantees that only one version of this very library is loaded at runtime. So now let's imagine a conflict situation with different majors. In this case, only the highest version is loaded, the other version is not loaded. Only the highest version is loaded, regardless if it is backwards compatible or not. Here, you are taking the responsibility. It's like a typecast. You are taking the responsibility, but if it doesn't work, don't blame module federation. Well, the thing is, if you have a situation like this, you at least get a warning on the console. It tells you, hey, are you really sure you know what you are doing? If you don't want to have a warning, but a slap into your face, then go with strict version true. Strict version true tells module federation to emit a runtime exception and error if there is such a conflict situation. And I really love this because this makes me fail fast, and failing fast is a good thing, as this actually allows me to find out quite quickly about this issue. When running my integration tests, I will immediately find out, hey, there is an issue in there, let's try to fix it. You can even relax the version requirements. But one more time, if you do this, you are taking the responsibility. It's like a typecast, as mentioned before, don't blame backpack. But yeah, it's possible. You are the expert at the end of the day. And if you say, hey, I know this was compiled against version 10, but I'm using that little features, it works with everything between 1 and 11, then you could configure it. So let me recap. There are several baked-in options for dealing with version mismatches. However, of course, the best option is to avoid conflicts upfront. And how can we avoid it upfront? Well, this exactly leads to the second part I've prepared for you. It's the old discussion, mono versus multi. Shall we go with a mono repo or shall we go with a multi repo? And the answer is yes. You shall go with a mono repo or with a multi repo. Well, the thing is, both works. I've seen both working out there in the wild. However, both has different consequences. If we go with several repositories, you have something like I'm calling micro frontends by the book. This is how micro frontends have been originally described. Everything goes into a repository of its own. The borders between those repositories are quite strict. Hence, you have the maximum amount of freedom. You can do what you want in your vertical silo. You can use each and every framework you want, each and every framework version, each and every additional library like Redux or Nginx. This gives you the maximum amount of freedom. However, this freedom is not free, even though it's called freedom. This comes with costs. For instance, now you need to publish your shared libraries via NPM. And this is quite a pain, you know. You need to tinker an NPM library, you need to NPM publish it, you need to assign a version, first of all, you need to install it everywhere. Then you find out, hey, there is a bug, you need to check it out to fix the bug, to increase the version number, to publish it again, to install it everywhere, just to find out, hey, there is another bug. And this goes back and forth until you are crazy or done, depending upon what happens first. This is one reason why a lot of people switch to mono repos recently. Another drawback is, as you can do what you want in your silo, you will sooner or later end up with version mismatches. Because other than with microservices, micro frontends, single page application based micro frontends, what a term. In German, it's just one word, you know. Single page application micro frontends need to be downloaded into the browser. And this means we need to download several frameworks and versions if we have bad luck. And this also means we will end up with version conflicts. And trust me, your browser is the last place where you want to have a version conflict. Dealing there with it is everything but fun. That's why I'm saying this comes with a lot of freedom, but also with a lot of costs. And that's why more and more people are moving to a mono repo, are moving to using micro frontends with a mono repo. It somehow some kind of self-restriction. I'm restricting myself to one version of everything. But restricting myself has a big advantage. It's not that costly at the end of the day. I don't have that much pain. Because of this one version policy, I won't end up with version mismatches or different versions in the browser. Plus, sharing my libraries is a piece of cake. Just check it into your source control and, Bob's your uncle. However, now we don't have any strict borders anymore. No strict borders between our verticals, between our micro frontends, between our business domains. So how can we prevent that everything is intermingled with each other? Because this is also one of the goals of micro frontends, to separate them from each other, to don't depend on each other so that teams can work in an autarkic fashion. Well, the good message is you can prevent this coupling, this cable salad with linding rules. There are linding rules, for instance, provided by NX that allow you to define which part of the system is allowed to communicate with which other parts. And here we could say, well, here I'm in my domain boarding, it's about flights, and I'm not allowed to grab over to booking. You see it here, I try to load my booking domain module from the booking area. And that's why I'm getting a hit on my fingers, because I'm not supposed to grab over there. This can be enforced by linding rules like this. We get those errors or those warnings, it depends on your configuration during typing, but we can also get them on your command line. And so we can automate these checks. We can perform those checks before someone merges his or her source code into our main branch. And this makes sure that everyone needs to align with our architecture. As mentioned before, if you want to go with such linding rules, look up NX. It's really a nice set of tools that are very usable, not only for huge enterprise scale applications. And by the way, NX is just a superset of the CLI. It's basically the CLI with some extension points. Okay, let's come to the third topic I've prepared for you. It's about dynamic module federation. Before, I've shown you that with module federation, we can map paths to some URLs pointing to other micro frontends. However, if I'm doing something like this, I need to know about my micro frontends upfront, which is quite a static situation, isn't it? Normally, I don't know about my micro frontends upfront. Neither I want to know where to find them, nor I want to know how many of them we have. Hence, I want to get rid of them. And that's totally possible. Everything you need is a helper function, a drop-in replacement for import, a helper function that is using module federation at runtime to grab something from over there. Here you see, it gets all the key data to identify the application over there and the ECMAScript module here, CMP, to load. That's everything we need to go with. And of course, here, this is a helper function I've handwritten, but at the end of the day, it is using the module federation runtime API. If you compile something with module federation, several objects are just there at runtime in your global namespace. And I think we all know what I'm referring to when using the term global namespace. Okay, let's try this out. So in this example, I'm switching to my shell. The shell has a webpack configuration. And here you already see I've commented out this path mapping because this is too hard-coded for me, too static. Nevertheless, I'm still going with my shared mappings. with the libraries I want to share. Then let's move over to my app routes file. Here I'm using a lazy route. That means everything looks like lazy loading for Angular. But instead of going with import, I'm calling this helper function load remote module. I'm pointing to the URL over there. I'm pointing to the exposed module, which is in turn exporting an Angular module. Here you have the static alternative that is just going with an import statement. Switch out import by load remote module, and you know, Bob's your uncle. I don't know why Bob's your uncle, but he is, trust me. Okay, cool. So perhaps you're saying now, well, this is not dynamic enough for me, because here still I need to know about the number of my micro frontends. Everything is dynamic, like this URL that can come from everywhere, from a constant, from a configuration file, or from something else, but it's too static because I need to know about the number of the micro frontends. So let's make it a bit more dynamic. Let's comment this out. Let's move over to my app component. And here I have some magic lines of code. Normally, of course, you would move this to a service, but for the sake of simplicity, I'm just going with my app component here. And here you see, I'm creating the additional routing entries by hand. We can all imagine that we can tinker this data structure by hand after looking at some data we've received from a configuration file or from the server side. Then I'm merging this with the static routes I always have. Static routes like my home page. And then I'm telling the router, hey router, it's showtime. Please configure yourself once again with this new routing configuration. Little tiny trick. If you want to prevent issues with deep linking, move this to an app initializer. Initializer, yeah. Then, you know, Bob's your uncle. And that's it. And I think we all can imagine that we also can tinker those main menu items and hyperlinks by looking at this data we've received from the backend. And as you see here, it still works. Awesome, isn't it? Now we can go fully dynamic. Okay, before I close, let's also talk about this guy here. No, it's not a college picture of mine. It's the Frankenstein. You know, this guy that was assembled of different parts of different dead people. And we've already heard before from Luca that this is very likely an anti-pattern. And yes, I totally sign this. It's really an anti-pattern to mix and match different frameworks and framework versions. However, as Luca already mentioned, sometimes we need something like this. If there was a merger in our company, if there was the need for buying something from a third-party vendor, or if we need to migrate from an old technology stack to a new one. We have this from time to time. Every 10 or 20 years, very likely we need to change the tech stack. And so sometimes this can be useful, but we never do it upfront and we never plan for this upfront. However, it's always good to know that it would be possible if we really need it. So how can we load something that is using a different version of Angular or using a different framework? Well, we've seen so far that module federation allows us to load something from over there, from a separately compiled and deployed application. And so far, this something was a component or an ng module. However, no one prevents us to load the main file of another single page application. The main file that emits a bootstrap function, for instance. This allows us to bootstrap another single page application into the middle of ours. And so we have everything nicely integrated. Of course, when bootstrapping and single page application, we need a root element. We could write it by hand. And very likely we can get rid of this bootstrap method because most of the main files are self-bootstrapping. All the single page applications out there are self-bootstrapping. And then perhaps you want to wrap this into an Angular component because you can root to an Angular component. And so you can also root to another single page application. Of course, this comes with several challenges. We need some workarounds. I've implemented some of them here in this library, so check it out. It's an add-on library to our module federations library. But if you go down this rocky road, then you have something like this. You have the best of both worlds. Namely, because of going with different single page applications, you can have different frameworks and or versions. And because of going with module federation, you can share one version if this version is needed in several applications. So you have the best of both worlds. Let me show you a demonstration for this Frankenstein. Here I've already prepared a root. And as you see here, this root routes to a dummy Angular component. I'm calling it the web component wrapper. Basically, it is a generic Angular component that uses module federation to load something from over there. This something is in this case a web component. And we all know web components are self-bootstrapping. They are registered with the browser. And if somewhere their element occurs on the web page, then the web component is mounted in there. So if I have something like this on my web page, then the web component is created in there. If I'm throwing this away, then the web component is unmounted. Inside of this web component, I'm running a React component, as the name here implies. So this is basically everything this wrapper is doing. Loading a web component from over there and creating an element with the respective name. For the case that this web component is using a router of its own, I'm telling Angular to just look at the beginning of the root at React, because everything that comes after React is the business of this very single page application, of this React application. The router in there would take care. Hence, here I'm not going with a path, but with a matcher and a helper function that just looks at the beginning of the URL. And that's it. So let's have a look at this. Surprise, and hey, here we go. We have a React application inside of our Angular application. How cool is that? And we can go even further with this approach. Here I have a live example in the Azure cloud. Here you see I'm loading a React application. I'm loading another Angular application. This Angular application is using Angular 12.03, while the shell is using Angular 12. However, 12.03 is only loaded once. If we need it again for this second application, we are sharing it. If we need it again for the third application, we are sharing it again. This all works together with subrouting. I have a view application. In my point of view, this nicely shows that we can mix different technologies. And here we have an Angular JS application. If you ask me, this really shows us that we can migrate little by little from an old technology stack to a newer one with this architecture. And here I have a dashboard. Prevent this if somehow possible, because this kind of fine-grained integration of several frameworks is even more rocky. So as Luca before mentioned, decide between or distinguish between micro frontends and components, and if somehow possible, avoid such a fine-grained integration. It's always better to go with an integration on a domain level, on a level of a main menu item. So if you want to know more about this, you can find a lot of details here in my free ebook. Download it here at angulararchitect.co/book. It has about 120 pages and explains everything you need to know when you go with module federation, and even a bit more like an accent domain-driven design. Okay, let me come to a conclusion. We've seen module federation ships with a lot of baked-in strategies for dealing with version mismatches. However, the best strategy is to avoid them upfront, and so you can restrict yourself with a mono repo. This forces you into a one version policy. However, this prevents issues with conflicts upfront. Webpack allows you to do everything in a dynamic fashion. There is the Webpack runtime API. You can tell at runtime, that's why it's called the runtime API, to load something from over there. And the Frankenstein is possible. You need some dirty workarounds. We've automated them with our library. However, the road is quite rocky. It's a hit on your bundle size. If you can avoid it, avoid it. But it's good to know that it would work if we really needed it. And that's it. So thanks for having me. I've already uploaded my material to my blog. You'll find the slides and the examples on the start page, on the homepage, and follow me on Twitter to stay in contact.